Okay, welcome to Grumpy Science, the next installment with Bob Dennis and Mark Tommerdahl at the Secret Science Laboratory here, bobslab.com. You can always write us questions and we'll try to answer them, but today we've got a little bit of history on the brain gauge. And so since Mark Tommerdahl was the primary person driving the history of the brain gauge, I'm just going to go ahead and let him show you. Now, remember, this is a little bit of an earlier version, right? Now the brain gauge is available in something that looks an awful lot like a computer mouse. It's actually an old version of the brain gauge, but it started off a lot bigger and more cumbersome than that. So I'll just let Mark take away.
Yeah, the brain gauge actually was born when Bob moved across the hall from me, and
at the university.
At the university, not across the hall in our dorm.
Yeah.
But anyway, we started commiserating in the late afternoon about what could we do if Bob was interested in the kind of work we were doing, and I went and used a whiteboard that looks a lot like this, except we didn't write Grumpy Science on it. And a lot of the ideas were about cortical interactions and using the somatosensory system to basically study the brain and how the brain works. The brain can be studied very effectively with somatosensory system, and this is what I spent several hours convincing Bob of. And then once I convinced him of it, he said, "Well, that's great." He said, "So I tell you what, why don't we present this to my senior design course, a bunch of undergraduate engineering students who would work on a project like this." And before any university administrators get their panties in a wad about university students actually inventing the brain gauge, we might mention that the senior design group did work very hard on trying to do this. And as many undergraduates do, especially in the spring semester of their senior year, they basically didn't do anything that was worthwhile. Bob took a weekend and some plastic parts and some fishing wire,
tape,
and got something put together that worked.
Yeah.
And out of that device, we actually generated.
Not kidding. Actually, there was fishing line.
We actually generated some papers, and those papers and the pilot data that we collected proved beyond a shadow of a doubt hypothesis that we'd been declared crazy about. But basically, we submitted that and got a bunch of funding to build the world's first portable tactile stimulator.
You can actually read about these papers. They're posted on corticalmetrics.com, right? I mean,
yep,
you've got all of them there. So yeah, you can go ahead and put this here. So we're going to show you it's from the museum archives, Technological Museum Archives.
This was our very first tactile stimulator, and what you can see here,
look over here, lunchbox.
These two probe tips actually stimulated the back of the hand, and we picked the back of the hand because we were being geeky scientists and saying, where's the perfect place on the skin to do studies and compare one neurological disorder to another? And we didn't want to have any use-dependent effects. And when I say use-dependent effects, I mean, well, you don't tie your shoes or scratch your face very often with the back of your hand. You really don't do anything with it. So basically, this stimulator was designed to stimulate the back of the hand. You actually stick your hand in underneath it, and it would stimulate those two places on the skin. And lo and behold, the data we got from that across all subjects was incredibly good because there was no variability from one subject to the next unless there was something wrong.
003.
Yeah,
this was an early one.
Third version. So anyway, stimulate the back of the hand. And we got fantastic data, and then we started doing studies in chronic pain and autism and alcoholism, and we got just, from subject to subject, rock solid data. The problem with this is that it's not very clinic friendly. And what I mean by that is people get weirded out about sticking their hand under things, and so we had to come up with another design.
Unless you like noodling and going catfish.
If you ever going catfishing and going noodling, well.
So the thing is about that device, it had a lot of stuff in it. A couple of servo motors to put the tips closer and further apart. It is immensely complicated, as all things are when you start building them. It's very expensive for us, many tens of thousands of dollars, I think.
So the next version was next thing we want to do is, well, how do we stimulate the fingertips? So Bob gets a lot of credit for this. This is a lunchbox.
Put it up on the stand, man. Show them the whole thing.
Okay.
You got it down there next to you.
Yeah.
This is the mobile somatosensory testing system that we built. It's actually comes apart. You can take this part off and you can put your hands on it. You can see a picture of this.
Lunchbox out of the way now.
You can see a picture of this at on the Cortical Metrics webpage, right? And the idea here is that these discs can be rotated so that you can get them located where the fingertips are. And then you've got these precision, optically precise, controlled, high-speed vibratory stimulators for the fingertips. And you can do somatosensory experiments. The big lunchbox thing, that was for all the electronics that went with it. But the next, 2 years, we were able to compress all that electronics that was in that big lunchbox thingy right into here. Right. So then it just connected straight to a computer. Right. So we kept reducing the size, reducing the complexity. But every time we reduced the size and complexity, we'd always increase the performance. So it really wasn't a question of just trying to dumb it down and make it small. It was a question of making it better and better and better and more efficient. So there's that one. And
so after we got this so that it would plug directly into the computer and be USB compatible, the next step was the brain gauge, and that's basically
so that's basically like, a computer mouse. So the trick that we used was we hired a bunch of really smart students, right? Who, well, they weren't just students; they had PhD in your laboratory. So and I was on their committees and stuff. So they started from somewhere, right? And we worked with them for many years, and some of them worked for us for like a decade almost.
They're still there.
They're still there. Yeah, we haven't fired anybody as far as I know. Nobody's quit. So anyway, the result was this, and we actually have some brilliant people working in the laboratory now making these things smaller and better and wireless and higher precision, higher performance overall. And the reason that all of that matters is that super high precision, super high performance of this somatosensory testing allows you to get better and better measures of things like reaction time and so forth, better somatosensory testing so that we can say a lot more about how your brain is working.
Right, and some of the things that we have to do, the reason this has to be precise is you have to deliver very precise stimuli to the fingers so that you activate cortical regions that are side by side in the brain, and we can actually see what the effect of those interactions is.
Yeah, and very subtle changes in those interactions too. Remember, I mean, some of the comments on one of our earlier videos was, well, you got to worry about the calluses on the skin and blah, how cold it is and all that stuff. Yeah, we do worry about that. In fact, that's part of the design. We measure it from 2 fingers and then we cancel that out, right? So we're looking at differences. And so our ability to apply different stimuli to these 2 tips is what's the positional accuracy is better than a micron, right? It's like
correct.
A third of a micron or something like that, and less than a millisecond. So in terms of reaction time and displacement, amplitude, discrimination, all those things, once again, this is a scientific instrument, and it just keeps getting better and better, and smaller, more and more efficient and less expensive. So how long did, you and I started working on this together almost when I started at UNC.
2004, 2005,
2004. So we've been hacking away at this problem for like 14 years.
The takeaway message is we crammed this big lunchbox,
computer mouse,
big lunchbox down into this.
And I haven't had any beer yet. I'll try to feel better about it later tonight, right?
Yeah, but the bottom of it, the reason we like to show this is simply because showing the history's always important. We'll talk about that in the next video.
Especially when you're old.
But you gotta act like you've done something.
Yeah, when I was young. Anyway, so we put a lot of time, and it's been a lot of time, into building like the world's most useful, precise computer mouse for doing somatosensory testing, and that's what this is. And there's a long history to it, and a lot goes into it. So,
I might mention that before this big beast got built, there was no portable tactile stimulator. This is the world's first dual-site portable tactile stimulator,
I think we had a single site one, right, called a Chubbuck?
We had a single
which is like
site
the size
one.
of a refrigerator. And I think they're like $70-something thousand, and when you turn them on, the lights go dim.
Yeah,
I think
they're pretty big, and they were the standard, but you know, they were designed by a guy.
Well, they're really good. Yeah,
they're very
they're
precise.
Single site stimulator to see what would happen with different mechanical, tactile stimulus and how it affected the brain. Totally good science. There's many important papers. Yeah.
Now we've talked about the history of how we developed this, and in the next video we're going to talk a little bit about why it's important to study things with somatosensory stimuli, with tactile stimuli, mainly because it is the best way. But anyway,
yeah, there's good scientific reasons. So first of all, we have to be able to make a good measurement, but we will talk about why that's the best way to make the measurement to determine what you want to determine about brain function. We'll talk about that next time. But for now, it's been almost 11 minutes. I'm getting tired.
Yeah, it's time for another beer.
We'll stop, and we'll come back at you later. Thanks.